The year 1665, a young man sat alone in a quiet countryside house. Outside, the world was full of chaos. Plague was spreading, cities were shutting down, and universities were closing. But inside that house, something extraordinary was happening. A falling apple, a simple moment that would change science forever. That young man was Isaac Newton, and what he discovered during isolation would reshape how we understand the universe itself. Gravity, motion, light, mathematics. Everything we know today about physics traces back to him. But Newton's story is not just about genius. It is about obsession, isolation, rivalry, and a mind that never stopped questioning reality. Isaac Newton was born in 1643 in Woolsthorpe, England. He was born prematurely and so small that many believed he would not survive. His father died before he was born. His mother later left him to be raised by his grandmother. From the beginning, Newton was alone, and that loneliness shaped everything. He was not a social child. He preferred machines over people. He built small models, windmills, water clocks, mechanical devices, long before he understood the science behind them. At school, he was not considered a genius. In fact, he was average, but something inside him was different. He didn't just learn things. He questioned them. Why does the wind move? Why do objects fall? Why does the moon not fall into the earth? These questions never left his mind. Newton eventually entered Cambridge University, but even there, he was not immediately recognized. He studied mathematics, philosophy, and natural science, but most of what he learned was outdated. So Newton did something unusual. He taught himself. While others followed old scientific ideas, Newton read everything, then questioned everything. He studied the works of Galileo and Descartes, but he didn't accept their conclusions blindly. He wanted proof, real proof. During this time, Europe was undergoing a scientific revolution. People were beginning to challenge old beliefs about the universe. But Newton would take that revolution further than anyone imagined. In 1665, the Great Plague hit London. Cambridge University closed. Students were sent home. Newton returned to his family estate in Woolsthorpe. This period is now known as his Annus Mirabilis, his miracle year. Because in isolation, Newton made his greatest discoveries. He began studying motion and mathematics. He developed early versions of calculus. But most famously, he began thinking deeply about gravity. One day, as the story goes, Newton saw an apple fall from a tree. This simple event sparked a revolutionary question. If the apple falls straight down, could the same force reach much farther? Could it reach the moon? Could it be the reason planets stay in orbit? Instead of seeing the apple as ordinary, Newton saw a universal law hiding inside it. Everything that falls must be pulled by something. And that something became his greatest discovery: gravity. Newton proposed something shocking. Every object in the universe attracts every other object. The force depends on mass and distance. This idea became the law of universal gravitation. It explained why apples fall, why the moon orbits Earth, why planets orbit the sun, why tides rise and fall. For the first time in history, humanity had a single equation explaining both Earth and the heavens. Before Newton, people believed the sky and Earth worked differently. Newton proved they obey the same laws. This was a turning point in science. The universe was no longer mysterious chaos. It was mathematics. In 1687, Newton published his most important work, Philosophiae Naturalis Principia Mathematica, also known as the Principia. In this book, Newton explained the three laws of motion: gravity, planetary movement, mathematical principles behind physics. These laws became the foundation of classical mechanics. His three laws were simple but powerful. An object stays at rest or in motion unless acted on by force. Force equals mass times acceleration. Every action has an equal and opposite reaction. These rules still govern engineering, rockets, cars, airplanes, and even space travel today. Without Newton, modern physics would not exist. But Newton was not just a brilliant mind. He was also deeply complex. He worked alone for most of his life. He had conflicts with other scientists, including Robert Hooke and Gottfried Wilhelm Leibniz. He could be extremely defensive of his ideas. At times, he became obsessed with proving others wrong. Later in life, Newton worked at the Royal Mint, reforming England's currency system. He also spent years studying alchemy and religious texts, searching for hidden truths beyond science. Newton's mind never stopped working. Even when the world moved on, he stayed inside his thoughts. Isaac Newton died in 1727. He was buried in Westminster Abbey, honored as one of the greatest thinkers in history. His discoveries changed everything: physics, mathematics, astronomy, engineering. Without Newton, no space exploration, no modern physics, no satellites, no rockets. Even today, scientists build upon his foundation. But perhaps his greatest legacy is not his equations. It is the idea that the universe is understandable, that behind every falling apple, every orbiting planet, every motion in space, there's a law waiting to be discovered, and one curious mind can find it. Claquete outro, final, 20 horas. A single man, sitting in isolation, changed how humanity sees the universe. Not with power, not with technology, but with thought. And that man was Isaac Newton.